Go through the full business of using amplitude, period, and median all being moved at the same time. So our median in this case is going to be equal to -1. Our amplitude is just going to be equal to 2. And our period is going to be equal to, and now this is a little bit hard to read, but it's actually a half. So this is going to be 2 pi on the absolute value of a half, and we can work that out to be 4 pi. So the period in this case is actually going to be 4 pi. Alrighty, well with our amplitude and our median, we can work out that the maximum is going to be -1 plus 2, or 1, and our minimum is going to be -1 minus 2, which is going to be -3. Basically, 2 above -1 and 2 below -1. Alrighty, so that's all the information we need, and now we can just draw our axes and have a go. So our y-axis needs to show the numbers -3, -1, and 1. So for -1, that's going to be our median. And I'm going to try to evenly space 2 above for our maximum, and then 2 below for our minimum. So that's -3, +1 for our minimum and maximum, and our median, the number in the middle, is going to be -1. Now to cos function. Cos function starts at a maximum. Now we need to set in our x-axis. So 4 pi is our repeating, and it's also how far we're going to be drawing. So 4 pi is going to be over here. Halfway between is going to be 2 pi. Halfway between again is going to be just pi. Halfway between 2 pi and 4 pi, guess what? It's 3 pi, because we're counting in pi's. Now, how does it work? Well, this function goes top, middle, bottom, middle, top. So top, middle, bottom, middle, top. And now we can just draw in our curve. And there we are. I'm just going to fix this up a little bit. Alrighty, and so there is our first graph. Let me just label my x and my y-axis, and we're all done. Alright, let's have a go at the same thing with the tan function. Now just as a reminder, the a value for a tan function means basically nothing to us. Might change where our intercepts go and stuff like that, but in the end, we're not solving for any of that at the moment. So instead, we're just going to worry about the two main things, which is that the median is equal to 1, and that the period has been affected by b. And remember, it's pi on the absolute value of b, because remember, tan's period is different. So it's going to be pi on the absolute value of 2, which is just pi on 2. So pi on 2 is how often it's going to repeat. And we're going over the domain negative pi to pi, so we're going to have some negative x-axis as well as some positive x-axis. Alrighty, so there's my x and y axes set up. Now remember, our median is at 1, so I'm going to just draw a horizontal line at 1. That's where my zeros are going to go, but it's not going to change where my asymptotes go. So we're starting with a 0 here, and that is going to repeat after pi on 2. So let's go pi on 2. 2 pi on 2 is just a pi. And let's go the same thing in the reverse direction. So negative pi on 2, negative pi. Alrighty. So all of these are going to be zeros, because this is in line with our period. And with a tan function, halfway between our zeros is always an asymptote. So I now need to work out these halfway points along the axes as well, which is going to be pi on 4 and 3 pi on 4, and then the negative equivalents. And at each of those, there's going to be a vertical asymptote line. One of the things we haven't looked at really much is reflections, and we can tell it hasn't been reflected because neither the b value nor the a value are negative. And that's the only thing we have to worry about, at least with the tan function. But with the cosine and a sine function, we do have to look at both the x and the the A and the B values to check that nothing has reflected. But since it hasn't, it is going to be a standard increasing. And there is our sketch. And once again, we're not going to go past pi because that is our domain we've been given. So negative pi to pi, that's our full domain. You can see we get quite a few repetitions within that small little area. Alrighty, see you in the next one. Goodbye.